Okay, so welcome to the 29th day of Stay at Home, Stay Safe. Last time that we did a video talking about the fact that we broke the shooter and we pulled it apart. And now we're going to talk about putting that shooter back together. Before I start doing that though, I want to spend a few minutes just talking about timing pulleys and belts. Okay, so in my hand I have a 70 tooth 5mm HTD belt and a 110 tooth 5mm HTD belt. Okay, now what does that mean? Okay, when I say it's an HTD belt, HTD is the type of profile. So if you look at the profile of these teeth, they're rounded up. They're almost a little more than half circles. Okay, that's the HTD part. 5mm is the pitch. The pitch is the distance between the center of one tooth to the center of the next tooth. Okay, so these are 5mm pitches. Okay, the number of teeth on a belt, okay, really just indicate how big it is, how long it is. Okay, 70 teeth at 5mm gives you a belt this big. 110 teeth at 5mm gives you a belt this big. Same holds true if you look at your pulleys. Your pulleys, this is a 28 tooth 5mm HTD pulley. Its diameter is this big. A 40 tooth 5mm HTD pulley has a bigger diameter. If I take an 18 tooth, it's smaller. Okay, so the number of teeth on these really is an indicator of how big they are. Okay, so when we put belts and pulleys together, there are a lot of things you need to take into consideration. For example, you need to know how far apart your two shafts are. Okay, so if I take these two 24 tooth pulleys, okay, and I put them on a 70 tooth belt, my centers are about 4.5 inches apart, which is what conveniently we have on the shooter. Okay, on the other side of that shooter, we have two 34 tooth pulleys. Okay, they are connected by an 80 tooth belt so that we get that same 4.5 inch distance on center. Okay. One of the other big things that you need to take into account when you're doing a pulley setup is how much of your teeth are engaged. So if I take a 40 tooth and an 18 tooth and I put them onto a 70 tooth belt, you can see over here on my little pulley, not very many teeth are actually engaged with the belt. Okay. If I take those same two pulleys, put them on a 110 tooth belt, okay, now you can see that more teeth are engaged on that small pulley. But it also increased my distance much farther than I have room for on this shooter. Okay, so that is a quick primer on pulleys and belts. There is a tool on West Coast Products that allows you to take your two pulleys, put in the number of teeth you have in each, how far apart you want your centers, and it will tell you which two belts would fit that combination. Okay?
And we can link that tool in the description of this video.
Okay. So, on our robot now, one of the first things I want to talk about is our failure points that we found. Okay. The first one was this pulley was sliding in towards the motor mount, okay, to the point where you could see no spacer. Okay. This was our spacer. Now the problem with this spacer is it has as its internal profile a hex. So when I put this spacer onto a hex shaft, this spacer is going to spin at the same speed as our shaft. Okay. Now the problem that creates for us is because this pulley wants to keep pushing on it, okay? We, in essence, created a really fine grinder because our spacer is being pushed up against the motor mount and then spun really fast, so it's grinding off the material until it slides into the motor mount, and then it grinds off some more, okay? Now, we were fortunate enough to catch it before it did any damage to our bearings on the inside, but so something you want to watch for. This is actually a better spacer. It has a circular inner profile, so that as that shaft spins, this spacer, in essence, just kind of sits there, okay? Now, here's your second issue. Okay, this particular spacer has a huge variation in width as you go through it. Okay, now I don't know if that was a wear problem because it doesn't really look like it. It looks more like it was a cutting problem.
Yes, it was.
So we want to be careful when we make these spacers to make sure that we get a good cut on them. Okay, so those were a couple of issues. Now here was the issue, and it was the reason why I thought that I didn't understand how pulleys and belts worked. So this is a 24-tooth pulley from Vex. It turns out this is a 26-tooth pulley.
Whoops.
As opposed to 24. So in essence, what was happening is on the side where this is being driven, we're driving our shooting wheels 8% faster than the motor on the other side is trying to drive that wheel assembly. Okay, not real great, not catastrophic either. Okay, but we need to pay attention to those things also. Make sure we're getting the right parts on there. It's really unclear who picked this 26-tooth pulley out of the bin because it's the only one we have. But regardless, we didn't have a speed ratio of 1 on this side. We had 1.08. The other side had 1, so they weren't matched up. All right, so now we're going to talk about putting this thing back together. One of the things that we wanted to be able to do was we wanted to be able to shoot from behind the trench. And right now we just plain don't have enough speed on our flywheels to do that. So the way that we fix that is to create a gear ratio or a speed ratio greater than 1. Okay. Initially, Rich had spec'd out to use a 40-tooth and a 28-tooth with an 80-tooth belt. And the numbers all look fine on that. However, I only have one 80-tooth belt, so for the immediate, that's not going to work for us. So we needed to come up with a better scenario. Okay? So just as an aside, if you take 40 teeth and divide it by 28 teeth, you get 1.43. So in essence, our wheels will now move 1.5 times faster than they moved before if we ignore extra friction that might be created or inefficiencies. Okay, so we have 70-tooth belts. So that's what we're going to use, and that's what we're going to attempt to size for. So I went out to West Coast Products, and I'm looking for something that creates a ratio around 1.43 and has a on-center distance between 4.3 and 4.7. Okay, now how do we manage that variable distance between centers? If you look at our motor mount, we have one screw that is fixed solid into a single hole. That's on the bottom left. You'll notice that the other screw hole is in a slot. So as you move that mount either to the front of the slot or the back of the slot, it changes our distance between the two shafts so that we can account for a little bit of tolerance. Okay? So the numbers I found when I went online to West Coast Products was 28 and 18 with a 70-tooth belt. So I have a 28, I have an 18. It creates a ratio of 1.56 and its centers are 4.6. Okay? That's still within our tolerance, okay? And we still get reasonable tooth engagement on our small gear, okay? So when we end this video, we're going to go ahead and put these together. Unfortunately, we cannot test the shooter in the house. Ceilings are too short, not to mention the fact I don't have that long of a runway, and it is too windy to go outside and actually get any kind of a reasonable test going. So as soon as we get good weather, we'll head out and make a new video of the new distances we get with this new gear ratio. All right, so see you all on some future day of COVID-19 quarantine. Okay, so Samantha is getting ready to put on this new timing belt and pulley. So she's laid out all of the parts for one side of the robot on this table, and on the other side of the robot, she's laid out all of the parts for this side. So she's going to go ahead and she's going to start putting things together. Okay, so now you're going to notice on the motor she's working on right now, she had to put on a hex sleeve to make this work. Okay, that hex sleeve is keyed. Okay, and now she's putting on her spacer and her 28 tooth pulley. Okay. Now she's going to put a washer on to hold everything in place. And I'm not sure exactly what part this is called.
And neither am I.
If you know what it's called, you can comment in the comments as to what it is.
I cannot remember the name for it, but I know what it does.
She's just going to use a pair of pliers to push this on.
These are a pain in the butt and I do not like them. They're useful, but I do not like them. There we go. Now that will go on.
So now she's hung a 70 tooth belt from that. Now she has a spacer on the upper.
And now I'm going to have to move this.
Right, so now she's got to adjust her center spacing on between her two shafts. Okay, so put that pulley on there first and then you can stretch it out to match.
Yeah, I'm trying.
Okay, so it turns out it just took more hands.
Yeah.
So we now have that on there.
Woo! So now we can move this.
So she pushed it forward to get enough room to get the belt on, and now she's pulling it back to create some tension.
Yep. Come on. See what it's in there. There we go. There we go. And now I just gotta put this shaft collar on there. There we go.
Okay. So now we're going to do the same thing to the other side.
So now I'm going to put this spacer on, the 28 tooth gear, and our shaft collar. Our other spacer, our smaller gear. Here we go. And our shaft collar. Then we can loosen this. There we go. There we go. There. there we go.
Okay, so now while we're here, we're going to take a look at this back section right here. Okay, and if you look, there is a huge gap between this shaft collar and here. Okay, so we need to go clean those up, because the other thing you're going to notice is that this bearing is pulled out. Okay, and if I push everything in, hold that robot, there we go. Yeah, I can't video undo this, so go ahead and push that in yourself.
Sir, please cooperate. When we push this in, though, all of these are getting out of alignment.
Correct.
So everything's out of alignment. It's not just the one shaft collar, unfortunately.
Right, so Sam's going to spend a few minutes putting that back together the right way. It should be a maintenance item, though, to make sure that all of our shaft collars are tightened down and are in the right spot.